Okay, so we finished off last time having a look at this, and we were looking for examples. Let me describe what is common between them. First thing that's in common is an oscillation is happening. An oscillation just moves something, is moving from side to side to side to side, kind of like how we've looked at pendulum swing before, whether it's the wave on the beach, whether it's this guy saying hello, or whether it's any other type of wave. They all involve an oscillation of moving from side to side in some way. Another thing that they're both doing is they are transferring some sort of energy. Yeah, the energy of the wave, the energy of the, of the kinetic here moving from side to side. All of our waves are an oscillation with a transfer of energy. Really, really important. For those of us who have done energy transfers before, you could pause this and do a quick recap of what type of energy is being transferred. So give that a little pause. Okay, so you could talk about the energy transfer of the guy waving hello. He's got chemical energy from his body, and it's moving to the kinetic energy of movement. Don't worry if you haven't covered energy transfers topic yet with me yet, so don't fret about that if you weren't sure on those. Okay, two type of waves that we're going to meet today, really important. So we need to be able to describe the two types of waves. It says that at the top, doesn't it? First one we need to describe is one called a transverse wave. I'd like you to draw what I'm doing right now. Transverse means we're moving up and down. Transverse means a cross. Okay, so here's a transverse wave, sorry, that I'm drawing going up and down like that. A transverse wave is something that goes across. Transport, it's taking something across to ports. Yeah, transgender, you're moving across two genders. Trans means across. This goes up and down, up and down.
Please, the following students should come to the canteen as soon as possible. 7P, Lucas. 7B, Rodrigo. 7P, Guadalupe. 7B, Olympia.
Wonderful. Okay.
Lucas, 7P. Rodrigo, 7P. Guadalupe, 7P. Olympia, 7B. And in year 8, Rocío, 8G, and Rafael, 8B.
Okay, so the second type of wave that we have is longitudinal. Longitudinal is ones that go backwards and forwards like this, backwards and forwards like this. It's a bit trickier to draw. Transverse waves, whoa, up and down. Longitudinal, a little bit like this. I've got two sketches we can look at. And this is how you could do this with a slinky at home. If you grab yourself a slinky or you Google, slinky waves or something, transverse, up and down like that, and longitudinal, backwards and forwards. We're going to get a little bit more detailed and explicit with our language, but to start off, that is enough. Okay, this is really important. Here's our waves transferring our energy, like we said before, not necessarily matter, and the two names, longitudinal, transverse, longitudinal, transverse. You can join in with me there, longitudinal, transverse, longitudinal, transverse. Okie doke. So, make sure you've got those drawn. Really, really important for us, okay? Make sure you've got those drawn, however you've managed to do that, okay? Here's some of those more explicit facts I was saying about them. When it comes to a transverse wave, the particles or the motion of the wave is moving up and down at right angles, at right angles to the direction that it's moving in. So it's going up and down at right angles to the direction that it's moving. The longitudinal wave, on the other hand, is moving back and forth in the same direction it's traveling, back and forth in the same direction that it is traveling in. Okie doke. Let's stop there for now.